PharmaPal.
Identification of Anastatica hierochuntica Methanolic-Leaf extract-derived metabolites exhibiting xanthine oxidase inhibitory activities. Welcome to our exploration of the fascinating world of hierochuntica. In this video, we'll dive into a recent study that uncovers the potential of this plant's metabolites in combating hyperuricemia and possibly even cancer. We'll discuss the methodologies used, the intriguing results obtained, and the implications of these findings for future research. So, let's get started. Hierochuntica, a plant native to Saudi Arabia, has been traditionally used for its medicinal properties. Recent studies have focused on its methanolic leaf extract, revealing a treasure trove of secondary metabolites. These compounds are not just interesting from a chemical perspective, they hold promise for treating conditions like gout and cancer. In this video, we'll break down how researchers extracted these metabolites and assessed their potential health benefits. Materials and methods. To understand the metabolites of hierochuntica, researchers followed a systematic approach. 1. Plant extraction. Leaves were collected, dried, and ground into a fine powder. They were then extracted using a methanol water mixture. 2. Metabolite identification. The extract was analyzed using liquid chromatography quadruple time of flight mass spectrometry, LCQ-TOFMS. This technique helps identify the chemical structures of the metabolites based on their mass-to-charge ratios. 3. Enzyme inhibition assay. The study focused on the inhibition of xanthine oxidase, XO, an enzyme linked to hyperuricemia. The effectiveness of the metabolites was assessed through in vitro assays. This rigorous methodology ensured that the findings were both reliable and significant. The results were promising. The analysis revealed 12 distinct metabolites, primarily flavonoids, known for their antioxidant properties. Among these, rutin, quercetin, and luteolin showed the highest potential in inhibiting xanthine oxidase. Rutin demonstrated a strong binding affinity to the XO active site, suggesting it could be a key player in managing uric acid levels. The pharmacokinetic properties of these metabolites were also evaluated, indicating favorable absorption and distribution characteristics. These findings illuminate the therapeutic potential of hierochuntica in treating hyperuricemia and possibly cancer. The implications of this study are significant. The identified metabolites not only exhibit antioxidant and anti-inflammatory properties but also show promise as anti-cancer agents. The toxicity assessment indicated that most metabolites are safe for further exploration, with only a few showing potential carcinogenic effects. This research opens new avenues for developing natural treatments for conditions like gout, which affects millions worldwide. In conclusion, hierochuntica could be a game-changer in the realm of natural medicine, providing a basis for future studies aimed at validating these findings in clinical settings. Before we jump into the figures and tables, let's briefly discuss the context of the study. The authors aim to explore the bioactive metabolites from the methanolic leaf extract of hierochuntica. They utilized various computational tools to predict the pharmacokinetic properties, toxicity, and potential therapeutic effects of these metabolites. Figure 1. Molecular docking results. Let's take a look at Figure 1, which illustrates the molecular docking results of the identified metabolites against xanthine oxidase, XO. What is molecular docking? Molecular docking is a method used to predict how a small molecule, like a drug, binds to a receptor of known 3D structure. In this case, the metabolites are being evaluated for their potential to inhibit XO. Key observations. The figure shows different binding affinities for each metabolite. For instance, quercetin and rutin exhibited the most favorable binding interactions, suggesting they could serve as effective inhibitors. Table 1. Pharmacokinetic properties. Next, we have Table 1, which summarizes the pharmacokinetic properties of the metabolites. What are pharmacokinetic properties? These properties include absorption, distribution, metabolism, and excretion (ADME) characteristics. They are essential for understanding how a compound behaves in the body. Highlights from the table. Molecular weight. Most metabolites fall within the ideal range of 150 to 500 grams per mole. Lipophilicity. The log p-values indicate good absorption potential. Solubility. The metabolites show varying degrees of solubility, which is crucial for their bioavailability. Figure 2, radar chart for oral bioavailability. Moving on to Figure 2, we see a radar chart depicting the oral bioavailability of the metabolites. Understanding the radar chart. The chart compares 6 properties: polarity, solubility, lipophilicity, flexibility, saturation, and size. The pink shaded area represents the recommended ranges for optimal drug-like characteristics. Key takeaway: most metabolites are within the recommended range, indicating their potential as effective therapeutic agents. Table 2, Toxicity Assessment. Now, let's discuss Table 2, which presents the toxicity assessment results. Why is toxicity assessment important? Evaluating the safety of metabolites is crucial before considering them for clinical use. This table outlines the predicted probabilities of hepatotoxicity, carcinogenicity, immunotoxicity, and mutagenicity. Findings: several metabolites, like luteolin 8C glucoside, showed low toxicity probabilities, making them promising candidates for further research. Figure 3, Venn diagram of binding classes. Next, we have Figure 3, a Venn diagram illustrating the binding classes of the metabolites with various endocrine receptors. What does this diagram show? The diagram categorizes metabolites based on their binding affinities: high, intermediate, and low. Key observations: metabolites like quercetin and rutin show significant binding potential, which could imply their role in hormone-related therapeutic applications. In conclusion, this research provides valuable insights into the metabolites of hierochuntica and their potential as natural xanthine oxidase inhibitors. The figures and tables we discussed today highlight the promising pharmacokinetic properties, low toxicity risks, and significant binding affinities of these compounds. Thank you for joining us today. If you found this video informative, please give it a thumbs up and subscribe for more content on biochemistry and natural products. Don't forget to leave your questions in the comments below, and we'll see you next time.
PharmaPal.